Hi, so today in this video we are going to cover chapter 5.2.1, which is transformations of the exponential function, vertical and horizontal shifts. So we're just going to jump right into it. I kind of covered this in the video before, kind of prematurely, but so we have, let me scroll to the bottom because they have it stated really nicely. Okay, so they have R, they do lowercase, x minus h, and then plus k. This h and this k should be familiar to you since we are coming off of the quadratic transformations in their functions. And they are going to function essentially the same way as well. When we're talking about transformations, I don't actually believe we cover vertical and horizontal shifts in this one. Not shifts, sorry. Stretches and compressions in this chapter. So I won't cover it in this one again. I actually covered it in the last video. But anyway, so similarly to our quadratic equations, if we have something like 2 to the x minus 3, this is going to shift our entire graph over to the right by 3, to the opposite of this, right? If we have something like 2 to the x minus 3 plus 4, it's going to shift things to the right by 3 and up 4. Very similar, very simple. It's not like there's actually a vertex or anything. You just got to shift your parent graph up. So let's just get into this. We have function f of x equals 1 over 4x, and it's transformed by shifting it up 2 units. What is the equation of the transformed function? Now, I actually think that they want this to be back in f of x equals, which is like really goofy to me. I'm not sure why they change it. Let me double check on that. Hold on. 1 over 4 to the x. Sorry. I probably should have done this beforehand, but here we are. Up to... Yeah, so now they want f of x. They were lying when they wanted y. They were being goofballs. They were pulling your leg when they wanted y last time. But now we're back to wanting f of x equals 1/4 x plus 2. And you might need parentheses, you might not. I did it with parentheses and it worked. I don't think it should matter, but anyway, this is it. We're going up by 2 units. That's our k, right? This one's telling us that the function f of x equals 4x was transformed, which resulted in the function f of x equals 4x minus 4. These options will be something like it was shifted down by 4, or up by 4, or stayed the same. So it will be down by 4, down by, well, in this case, down by, and then by 4 units. Or down, I guess this would be just down by 4 units. Later on, it has something like that. What happens to the point 0, 1 on the graph of f of x equals 3x if f of x is transformed to be 3, f of x equals 3 to the x plus k when k equals 4? That was a mouthful. So basically when we're doing, when we have something like a plus, it will just, we're adding it to the y, right? So this should be, this should be 4. Yep, 5. Sorry, 0, 5. My bad. And then this one should be what happens to the horizontal asymptote of y equals 0 when we are shifted. Sorry, I just lost my train of thought. What happens to the horizontal asymptote of y equals 0 of the function f of x equals 3x if f of x is transformed to be f of x equals 3, x plus k when k equals 4? Still kind of a mouthful. Basically, we're going up 4, right? So our asymptote is also going to go up. We're going to do y equals 4 because it's doing 0 plus 4 since we're going up 4. If we were moving down, it'd be minus 4, but in this case, it's positive 4. Don't forget the y equals, because that is the equation of the line. This one I did the answers because I want to make sure I get the wording right. And also, it kind of looks really freaky. It looks like a bunch of just gobbledygook. So let's just walk through this, okay? Where does every point on the graph of y equals r of x as long as r is greater than 0, so say 2, it cannot be 0 or -1 or any other negative number. R does not equal 1. We're not doing 1 because 1 to anything is going to be 1, basically. And then move to if the graph is transformed to y equals rx plus k when k equals 8. So in our example, we have 2 to the x plus 8. This r could still be r. It could be 12. It could be 42. It could be 999. I just put 2 to like maybe help you visualize. We're going up. The y value is going up because this plus is our y value, right? Every single time. And the x value, since we're just moving it up, nothing changes. We're just going up. It's very similar to like linear functions and our quadratic functions. When we have a horizontal vertical shift, nothing changes the y's or the x's. Where does the horizontal asymptote y equals 0 of the graph of y equals r to the x for r is greater than 0, r is not equal to 1, move to if the graph is transformed to y equals r to x plus k when k equals 8. The horizontal asymptote is going to basically be this plus or this minus. So it will be y is equal to positive 8. It's basically our k is equal to whatever that is. And it moves up 8 units and becomes the asymptote, like I said, y equals 8. The function f of x is shifted right 8 units. What is the equation of the transformed function? Okay, so we're going to the right? So we have 3 to the x, and we're going to actually do a minus 8. Because we switch them. It switches. It's just like the quadratic equations. You'll see that in a lot of functions coming up, where it actually changes to the opposite. The function f of x equals 3 of x was horizontally shifted, which resulted in a transformed function f of x equals 3x plus 5. So we know it's going the left because we have a plus instead of a minus, and it's the opposite, right? It's the opposite of what you think it's going to be by 5. Yep. Where does the point 0, 1 on the graph of f of x equals 1/4 x move to if f is transformed to f of x equals 1/4 x minus h when h equals -2? This one is going to be, we're basically shifting our x over by -2. And you would think, oh, we have a -2 here. We'll plug it in. That probably means we're going to the right? Because this is a negative when we switch. But actually, if we plug this in, it would be x minus -2, which turns it into x plus 2. So we're actually going left 2. So it will be -2, 1. The y value does not change. Next, we will have, what does the horizontal asymptote? Y equals 0 of the function f of x equals 1/4 to the x move if f of x is transformed to f of x equals 1/4 to the x minus h when h equals 2. The horizontal asymptote does not change. Y equals 0. Because we're just moving side to side. We aren't changing any case. What happens to every point on the graph of y equals r of x for r is greater than 0? R is not equal to 1, and if the graph is transformed to y equals r to the x minus h when h equals -8, same idea. You might think like, oh, it's a negative, so we flip the sign and go to the right. But again, this would be r to the x minus -8 because we are substituting it, right? So this would actually be x plus 8. So it decreases by 8. The x goes backwards. The x goes left. The y value will stay the same because we don't go up and down. The x value, what happens to every point on the graph of y equals r to the x for r is greater than 0, not equal to 1, and if the graph is transformed to y equals r to the x minus h when h equals -7. One thing to note is you don't need to worry about like this beginning part where like the r greater than 0, r equals 1 if it's confusing to you. It's just saying like, we just want to know like what the behavior of our graph is going to be from like here basically. We don't care about the part where it becomes fractions. Anyway, when h equals -7, the value, x value of every point decreases by 7. Again, it's the same idea because we're doing plus, we're doing minus and negative, which is plus. So we're going to the left. It's kind of confusing. It's trying to trick you. It decreases by 7, and the y value stays the same. So then if the function f of x is equals 5x is shifted down 6 units and right 8 units, what is the equation of the transform function? It's going to be so similar to what we have been doing with our quadratic formula stuff. So we have r to the x. We don't know what r is. It doesn't matter. Oh, wait, we didn't know what it is. Sorry, my bad. It'll be 5 to the x. X doesn't change. It's shifted down 6 units and right 8 units. If we're going right 8 units, we're going to do minus 8, and then we're shifting down 6. So minus 6 equals f of x. This would be our answer. Whew, last one. Answer the following questions. What happens to the point 0, 1 on the graph f of x equals 7x if f of x is transformed to f of x equals 7 to the x minus h plus k when h equals negative 7 and k equals positive 5? This will turn into, so we're going to be moving down points. We're going to be moving up points because this is positive. So this is actually going to turn into 0, 6, but we also are transformed h equals negative 7, which if we plug that in, that would be x plus 7, right? So we're minusing 7, so it'll be negative 7, 6. Same principle here. We are going to go up 5, so we'll do 7 plus 5, which is 12. And then we are also moving it over minus 7. So it's going to be negative 6, positive 12. And let me actually double check that one just to be doubly sure. I just want to make sure I'm doing good. Negative 6, 12. Uh-oh, wait, hold on. I think I did something wrong. 1 second. Okay, I accidentally did an error with addition. This should actually be 7 plus 5. No, not 7. Wait a minute. Now I'm tricking myself. I was on the wrong problem on my equation. No, I did it right. That should be 6 positive 12. I just was typing in my answers to the wrong problem on the homework, and I was like, oh, why is it wrong? But no, it was correct. Yeah, we're just doing basically the transformations. Yeah, no need to doubt yourself. Yeah, if you have any questions, please let me know, and I will answer as soon as possible. Sorry again for getting the videos out so late. I just have been super busy with my classes and my job and my life, basically. But yeah, if you have any questions, let me know. Have a good one.